Okay, so just wait a few seconds. Hmm. Let me set up my mobile system so that you guys can ask doubts. Let me set up my mobile system so that you guys can. Okay, fine. So let's get started. So today we will be doing. Wait. Fine. So today we will be doing tangents and normals. This is a topic of class 12. This is a topic of class 12. This is a topic of class 12 and it comes under the hood of applications of differentiation. What is curl and divergence? Oh god. Oh god. So you're gonna straight up ask me curl and divergence. Who told you about this? So curl and divergence is something which is used to define a vector field. Okay. I'm not actually sure. I have kind of forgotten. I studied curl and divergence in first year. In my first year. So curl is something. If I remember, curl is delta. Or so, for example, if you have a vector field V, then I remember curl is del cross V, and divergence is del dot V. I don't know if basically curl and divergence are a way of representing a vector field. So if you don't know what a vector field is, I guess you shouldn't be asking this question. Anyway, so it was rather interesting to see curl and divergence being asked here. Because curl and divergence it's not in JEE syllabus, I know. Maybe someone is trying to test me out. Anyway, but I know basic stuff. So let us get back to the topic. And the topic is tangent and normal. So as I told, it will come under the hood of applications of differentiation. Okay, so we studied that differentiation. We studied that differentiation is denoted as dy by dx, and we studied some basic rules and formulas. So basically, we studied some formulas. Then we studied chain rule in the previous lecture. Then we studied product rule, and we studied quotient rule. These are all the different rules of differentiations that we studied last time. And today I would like to continue on that and build up on the process of applications of differentiation. Because, for example, you studied trigonometry and then you studied application of trigonometry. In that chapter, you were asked to do some basic rudimentary tasks with the help of trigonometry. For example, calculate the height and distance between two bodies and stuff like that. So here also we will try to use differentiation in some real life problems. So before we get started, I would like to tell a little bit about myself. Okay, so yeah, so this is me, Saurabh. I am a IIT Delhi graduate. I graduated from IIT Delhi. from the electrical engineering department. Okay, I graduated from IIT-JEE from the electrical engineering department, and I will be mentoring you during this whole session. Okay, so if you have any kind of doubt that you want to ask me regarding preparation strategy, how which book to choose or which book not to choose, okay, which topic to focus more on, or what should you do if you don't know how, if you are not very perfect with the topic, then you can tell me. I will help you out. Fine. Okay. On top of that, these are my work experiences. Previously, I have worked with Nokia and Yahoo Japan. My specialization, the things which are studied in IIT specifically. And on top of that, I have 4+ years of teaching experience. I have been teaching and mentoring a lot of students for the last 4 years. So yeah. So let's crack IIT-JEE with India's largest learning platform, which is Unacademy. So if you want to take a plus course subscription, if you want, sorry, my voice is not very loud today because I've got a sore throat. It's not sore actually. I think that I have got something has deep down my throat. Something has bothering me. I guess it's a cut or something. Okay, so plus course. If you want to go for a plus course, these are all the benefits that you will get. You will get daily live classes, live testing quizzes, structured courses, unlimited access to all the things that you could ask. So basically, this is quite good if you want to take a plus course. Okay, you can download the app, and if you want to take a plus course, this is the best time. This is literally the best time. Why? Because as you see, the paradigm is shifting to online learning. Most of the learning these days are now being conducted to online. So I guess if you want to do that, Unacademy Plus is a really good platform. Is a really good opportunity to explore that. Also, you will find a lot of good educators. You will get all these facilities, daily life classes, tests and quizzes, structured courses on your Unacademy Plus. So if you want to take Unacademy Plus, use this promo code SK01. Use the promo code SK01 to get 10% discount on all Plus courses. And I would recommend you guys to hurry because it is expected that in few days or something, I don't know, but soon Unacademy is going to increase its prices. And if it's going to increase its prices, I guess it's better that you take the courses now so that you can get them at lower prices. Okay. Anyway, so let's get started. Tangents and normals. Okay. So suppose this is a curve. Suppose this is a curve, and the curve has an equation y equal to fx. Okay. Let p x1 comma y1 be a point on the curve. Let's say this is a point. Okay. So what is the tangent? What is the tangent? The tangent, this line is tangent, this is tangent. Okay, a tangent is a line. A tangent is a line on the curve at a point x1 comma y1 which touches the point and the curve. Okay, so this is the basic definition of tangent. So tangent is a line, basically this line, this is a line which touches the curve at a point x1 comma y1 only. Touches, okay, not doesn't intersect. For example, this is not a tangent. Okay, it is intersecting. I'm talking about touching. So basically, if this is a point, the tangent is something like this, which just touches it at exactly one point. It touches it. Okay, so it touches the curve at exactly one point, and that point lies on both the curve as well as on the tangent. So this is the tangent. Okay, this is tangent. So the definition of tangent is that it is a line which touches a curve at a point. Just grazes it. It's just like छू कर निकल जाना. That's it. Okay, that is the definition of tangent. What is a normal? Now, normal is a line which is perpendicular to the tangent. So, for example, this is the tangent, and if you want to draw normal, this is normal. normal at a point is a line which is perpendicular to tangent. Okay, so I hope you guys remember from your 10th class that if this is the slope of this tangent is m1, the slope of normal is m2, then two perpendicular lines have slope m1 m2 should be equal to minus 1. I hope this is if two lines are perpendicular, their slopes multiplied by each other will give you minus 1. m1 and m2 product will give you minus 1. Okay, fine. So this is the basic definition. I hope you guys don't have any doubt with this. Just look at the figures. I will explain the things again. This is the curve. Let me take a highlighter. Here's the point. This is the curve. This is the curve, and this is the point which you want at which you want to observe things. At this point, this is a line which touches this point and the curve. Okay, it just touches it. Okay, this line which touches the graph is known as tangent, and normal is another line which is perpendicular to the tangent. So this is tangent, this is normal, and they make an angle of 90 degrees. Okay, tangent and normal. If the tangent has a slope m1 and the normal has a slope m2, then m1 multiplied by m2 should be equal to minus 1. Because if two lines are perpendicular to each other, their slopes multiplied by each other will give a result of minus 1. Okay, fine. So let's move on to next section. Okay, now I have to establish its relationship with differentiation. I mean, why are we even studying this? There has to be a reason for studying this, right? We studied differentiation, and I told you that we will study application of differentiation. So what's exactly differentiation here? Okay, so let me take some more slides. So in order to define a line, sorry, to define a line, you need a point and its slope. So in order to define a line, you need a point which lies, so basically the point is P, which lies on the line. So if you want to write the equation of tangent, we have a point x1 comma y1, check. But what about its slope? You don't know anything about the slope. How do you calculate the slope? How do you calculate the slope? You want to calculate the slope. As it turns out, the slope of tangent at a point x1 comma y1 is the derivative of the curve, and you calculate the value of derivative at x1 comma y1. This is the slope of tangent at a point. So for example, this is a tangent, this is the tangent. Let me take a laser point. This is the tangent, and the tangent is drawn at a point x1 comma y1 which touches the graph. So we have a point, and what about its slope? The slope of this line is the derivative of this curve evaluated at the point x1 comma y1. The slope of this line is derivative of the curve evaluated at this point. So slope of tangent is the derivative of this curve. So this is an important relation which you should remember. The relation is slope of a graph, no, not slope of a graph, derivative of a graph, derivative of a graph at a point gives slope of tangent at that point. It means that if this is a curve and you try to calculate the dy by dx at this point, if you try to calculate dy by dx at this point, this would be equal to slope of tangent drawn at x1 comma y1. So I hope this is clear. If you have any doubts, you can ask in the comments, but I hope this is clear. This is pretty straightforward. Okay, fine. So now to write equation of a tangent, we needed a point and a slope, and we have both point and slope. We have the point x1 comma y1, and we have a slope which is equal to this. This is the slope. So what is the equation of a line? Equation of line is generally, this is the straight equation of straight line. This is from class 11th. Okay, so equation of tangent, what is the slope? Slope is dy by dx evaluated at x1 y1, and x minus x1 is same. This is equation of tangent. Remember this. Okay, try to note it down. I'm sorry, my voice is not very loud today because I've got a sore throat. Fine. What about normal? Hello Lalit. Yeah, I agree. My voice is not very good today because I have a sore throat. I take classes on an academy platform as well as here, so I have to shout at two platforms daily. So maybe that's why I've got a sore throat. Anyway, but I think I am fairly audible. If you increase your volume level, I am audible. Okay. So what about the normal equation of normal? See, we said that m1 multiplied by m2 is equal to minus 1. If you go back here, we said that this is tangent and this is normal. The tangent has a slope m1, normal has a slope m2, they are perpendicular, so m1 multiplied by m2 equal to minus 1, where m1 is the slope of tangent and m2 is the slope of normal. Which implies slope of normal is equal to minus 1 upon slope of tangent. Okay, now what is slope of tangent? This is slope of tangent, dy by dx, which implies slope of normal is minus 1 upon dy by dx. Okay, so this is, hello Dhruv, hello. वैसे तो wait, but I'm just creating new slides. Okay, I come live daily at 6:30. Anyway, so today we are studying tangents and normals. What is a tangent? If this is a curve, at a point x1 comma y1, tangent is a line which touches the graph. So basically this is tangent which just touches the graph, and normal is a line which is perpendicular to the tangent. This is normal and this is tangent. So touches मतलब छू के निकल जाना, just touch करता है. Okay, fine. And we said that slope of the tangent, slope of a line, thanks, the slope of the tangent at a point x1 comma y1 is equal to dy by dx. This is what you should know, that the slope of this line is, basically in order to write its equation, I want to write its equation, and to write its equation we need a point on the line and its slope. Point is already given, point is dy by x1 comma y1. What about its slope? So this is about its slope. Slope of a tangent at a point is dy by dx evaluated at x1 comma y1. Okay, so this is the explanation. Fine. So equation of a straight line passing through a point P having a slope m is y minus y1 equal mx minus x1. सर ब्लैक शीट यूज़ करना वो अच्छी लगती है. हाँ, मैं नेक्स्ट टाइम से ट्राई करूँगा ब्लैक शीट, क्योंकि काफ़ी लोग बोल रहे हैं, पता नहीं मुझे वाइट शीट थोड़ी ज़्यादा अच्छी लगती है क्योंकि यहाँ पे कलर का कॉन्ट्रास्ट अच्छे से दिखता है. ब्लैक शीट में क्योंकि ऐसा है ना, ब्लैक शीट में फिर आंखों में दर्द होता है, कॉन्ट्रास्ट क्योंकि काफ़ी कम होता है उसमें. Anyway, so y minus y1 equal mx minus x1. This is what you should know. So equation of tangent at x1 comma y1 should be y minus y1, slope is dy by dx. This is the slope is dy by dx. This is the slope, x minus x1. So y minus y1 equal dy by dx, x minus x1. This is the equation of tangent. Okay. And what about equation of normal? See, slope of tangent multiplied by slope of normal equal to minus 1 because they are perpendicular. So slope of normal is minus 1 upon slope of tangent. Okay, which implies slope of normal is minus 1 upon dy by dx. So equation of normal would be, equation of normal, we have a point x1 comma y1, the normal passes through this point and the slope is equal to this, evaluated at a point x1 comma y1. So the equation of normal is y minus y1 equal slope this is and so these are the two things which you should remember. Equation of tangent and normal. Okay, I will give you 1 minute to note it down, then we will do questions. Okay, fine. So this is a formal, this is what I taught just now. Equation of a tangent is this, and equation of normal is this. कैसे निकालते हैं? ऐसे ही निकालते हैं, I think. Questions please. Yeah, questions. So this is your first question. This is your first question. Try to do it. Prove that the tangent drawn at any point to the curve would make a acute angle. If you, this is the question. If you are able to do it, very good. If you are not, I will prove it anyway. So I will give you 2 minutes to prove this thing. Try to prove this. If you are done, please comment. कोनिक सेक्शन नहीं है ये, कोनिक सेक्शन से नहीं है. दिस इज नॉट फ्रॉम कोनिक सेक्शन. अरे नाइस, काफी अच्छे, नाइस. ध्रुव, if I remember you are in class 10th, right? Dhruv, I remember you are in class 10th. Anyway, so first you see that fx is x to the power 5 plus 3. यार तुम मतलब you are really amazing. तुम 10th class में होके ये क्वेश्चन कर पा रहे हो. This is really amazing that being in 10th class you are able to do these questions. Anyway, so this is fx. You have to prove that the tangent makes an acute angle with the x-axis. Now what does this mean? It means that if this is the curve, we have to prove that the tangent makes an acute angle. Means this angle is less than 90. For example, if you draw tangent here, you will get this is a obtuse angle and this is an acute angle. So this is what we have to prove. We have to prove that all the tangents have acute angle. Now what does that mean? Acute angle means that theta, the angle, this angle is theta, the angle lies between 0 and 90. It means that tan theta is between 0 and tan 90, which is infinity. So it means that tan theta is positive. And what is tan theta? This is slope. Slope is positive. And what is slope? Slope is dy by dx. So we have to prove that dy by dx is positive always. Okay, I hope this is clear. The angle which tangent makes with the x-axis, this is theta. It is said that theta is acute. It means that theta should be between 0 and 90. And since it is acute, tan theta should be between 0 and infinity. It means tan theta should be positive. If tan theta is positive, which means the slope is positive, because tan theta is nothing but the slope. If slope is positive, which means dy by dx is positive, because I just said dy by dx is nothing but slope of the tangent. So let's calculate dy by dx. So basically d of this is y, dy by dx. It would be equal to derivative of first. Okay, so this is the derivative. Now if you look at this, x to the power 4 is always positive, because even power of anything is positive, always positive. Okay, x square is also positive and 4 is also positive. So this is greater than 0, this is greater than 0, this is greater than 0, and which implies the sum of these numbers would also be greater than 0. So it implies that dy by dx is greater than 0. This is what we had to prove. Because if dy by dx is greater than 0, it means that the slope is greater than 0, which means tan theta is greater than 0, which means tan theta is between 0 and infinity, which means theta is between 0 and 90. So if dy by dx is positive, it means angle is acute. Okay, I hope this is clear to everyone. Shall we move to next question? I am giving you 1 minute to note it down. Anyway, so let's move on to next question. So this is the next question. The next question has two parts, first part and second part. The first part is find the equation of the normal to the curve. Normal, okay, normal. And at the point x equal to -2. The second is find the equation of the tangent to the curve, this at x equal to √3. So first try this, then this. Okay, first try this, then this. And if you get the solution, comment or tell me that you have gotten the answer. Okay, remember this is modulus. So we are doing tangents and normals, and this is the question you have. First try this, then the second. So we have two parts. In the first question you have to calculate the equation of normal, and in the second you have to calculate the equation of tangent. I am giving you some time to do this. You have 1 minute more to try it, then we will solve it together. Have you solved it, Dhruv? Are you done or not? Anyway, so let's try to solve this. So the first question is y equal mod of x square minus mod of x and mod at x equal minus 2. Now this is something which you should know about, that a modulus function is x when x is positive and minus x when x is negative. Basically modulus function के अंदर कुछ भी डालो ना positive आता है. For example, if you put 7 here, you will get 7. If you put minus 7.2, you will get plus 7.2. So if it is positive already, you get the same as answer. But if the whatever is inside is negative, it becomes positive by applying another negative sign. So if it is minus 7.2, you will get minus of minus 7.2, which is plus 7.2. So basically, in order to make a negative positive, you add another negative sign. Okay. So at x equal to minus 2, x is equal to minus 2, you should know that mod x would be negative. Okay, you should know that mod x would be minus x. So the inside mod can be written as minus x, and minus minus will become plus x. Okay, this you should know. Fine. Now we have to also understand what is the nature of the outside mod. The outside mod is x square plus x mod. Okay, now you have to understand that x square, when you put x equal to minus 2, it will be plus 4, and this will become plus 2. Okay, this will become minus 2. Okay, so this is 4 minus 2 is 2, which is positive, which means this modulus chi is positive. And if it is positive, the answer would be same. I have already told you, if the inside argument is positive, the answer remains same, otherwise it becomes negative. We saw that at x equal to minus 2, the inside one number was turning out to be a negative. X equal to minus 2 is negative, so we added another negative sign and it become plus. Otherwise, for the outside mod, you saw that if you put x equal to minus 2, you will get 2 minus 2 square, which is 4 and minus 2, which is 2. 2 is positive, so the answer would be same. Anyway, so we have y. Now let us try to calculate dy by dx, which is the slope of the tangent. It would be 2x plus 1. Okay, now we have a point which is x equal to minus 2. At x equal to minus 2, y is equal to minus 4 minus 2, which is 2. Okay, if you put x equal to minus 2 here, you will get the answer as 2. So the point is minus 2 comma 2, and the slope is 2 into x plus 1. What is x? X is minus 2. 2 into minus 2, minus 4, plus 1 is minus 3. This is the slope. Okay, this is the slope. Wait. Nice. So this is the slope. This is the slope of tangent, but we have to calculate normal. So slope of normal is minus 1 upon slope of tangent. And if you do this, if you solve this, you will get minus 1 upon slope of tangent is minus 3. So you will get minus 3, which is 1 by 3. So slope of normal is, we have calculated. The point was minus 2 comma 2. Point is minus 2 comma 2. So the equation of normal is y minus y1 should be equal to m, which is 1 by 3, x minus x1. So the equation is 3y minus x minus 8 equal to 0. Okay, this is the equation of, I hope we did everything right. It seems so. Oh, anyway, now let's try to solve the second question. The second question is, y equals sine inverse 2x upon 1 plus x square. Okay, I'm giving you a few minutes, try to solve it on your own, then we will solve it together. चलो बढ़िया, क्वेश्चन लगाकर मजा आ गया। तो अब ये वाला क्वेश्चन करो। दिस इज द न्यू क्वेश्चन। द क्वेश्चन इज calculate the find the equation of tangent to the curve. This is the equation. Sine inverse 2x upon 1 plus x square. Yeah. Yes. Top 500. Yes. Yeah, almost. JEE में तो हाँ इतना चलता है। मतलब this was my JEE rank, but anyway, I guess not top 500. But when I went to IIT, I got my branch changed. So it is equivalent to 500 right now. Anyway, so the equation we have is y equals sine inverse 2x upon 1 plus x square, and we have to calculate the equation of tangent. Now you see, we have to calculate dy by dx, because for a tangent equation you need slope. This will give me slope and this will give me a point. Okay, now yesterday I told you how to solve these questions. In these questions you have to use a substitution. If you see, y equals sine inverse 2x upon 1 plus x square. Okay, if you put x equal to tan t, what you will get? Y equals sine inverse, okay, you will get 2 tan t upon 1 plus tan square t. And if some of you remember, this is the formula of sine 2t. Basically sine 2t is equal to 2 tan t upon 1 plus tan square t. Now this sine inverse sine will cancel out, you will be left with 2t. Reso fast, yeah, कर सकते हो, मतलब reso fast is good. You can appear. At this point, what I will suggest you is try to do as many tests as possible. You can appear in reso fast test or in FITZE's FTRE. All these tests, they are mostly they are really really good. So if you want to enroll for this, I would really recommend you. Okay. ESAT is also good. So y equal to 2t. Okay, what was t? T is tan इधर चला जाएगा तो it will be tan inverse x. So y equal to tan inverse x. Now this is simple. We have to calculate dy by dx. It will be equal to dy by dx would be equal to 2 upon tan inverse x differential is 1 plus x square, and we have to calculate dy by dx at x equal to root 3. If you put root 3 here, you will get 2 upon 1 plus 3, which is half. So this is the slope of tangent. This is the slope of tangent. And what is the point? Y is equal to 2 tan inverse x. So 2 tan inverse root t. What is tan inverse root t? Tan inverse root t is pi by 3. 2 into pi by 3. So answer is 2 pi by 3. Allen scholarship, yeah, यार दे सकते हो. मतलब what I will recommend at this point is, since you are just in class 10, give as many tests as possible. For example, ResoFast, ASET and FTRE. ठीक है, विद्या मंदिर का भी होता है, BMC का टेस्ट होता है, वो भी दे दो. जितने टेस्ट हो सकते हैं दे सकते हो अभी at this moment. And I think you will be able to qualify most of them because you know a lot of stuff. Okay, so this is our y, this is our x. So finally we have x equal root 3, y equal 2 pi by 3, and slope is equal to half. So the equation of tangent is y minus y1 is equal to m, which is half, x minus x1. Okay, if you solve this, you will get 2y 4 pi by 3 x minus root 3. हाँ, और मुझे बताना फिर क्या रिजल्ट रहता है, क्योंकि I have, मतलब I think that you will be able to qualify most of them. Your IQ level is really good at this point, to be honest. So this is equation of tangent. So we started from here. This is step 1. This is step 2. And this is step 3. So you guys can note down. Now you can note it down. सर सिर्फ बायो और थोड़ा बहुत केमिस्ट्री की चिंता है। नोट इट डाउन। ठीक है, तो देखो ये दिस इज माय एडवाइस फॉर बायो एंड केमिस्ट्री। तो ऐसा है कि फॉर बायो यू हैव टू रूट लर्न स्टफ, यू हैव टू बेसिकली यू हैव टू डू रट्टाफिकेशन, यू हैव टू मतलब रटना पड़ेगा तेरे को। तो एट दिस पॉइंट व्हाट यू कैन डू फॉर बायोलॉजी, you just you make quick notes. Okay, you make quick notes of the things that you have studied and उसे रोज रोज रिवाइज करो, रिवाइज इट डेली. That is the best thing, that is the best possible strategy at this point to do for bio. For chemistry I would also say the same. chemistry में अभी तो ऐसा ही करना पड़ेगा, लेकिन बायो का तो यही चीज़ है, बायो के लिए you have to do a lot of rectification. Okay, so at this point let us try to solve this question. ठीक है, ये करते हैं. कल एग्जाम है, अरे बेस्ट ऑफ लक मैन. एंड ऑन अदर नोट ध्रुव, आई एम रियली प्राउड कि मतलब तुम काफ़ी मेहनत कर रहे हो. मतलब मोस्ट ऑफ द पीपल व्हेन दे कम टू यूट्यूब दे वॉच वीडियोज एंड स्टफ, बट यू आर एक्चुअली स्टडिंग, सो you have my appreciation. You can also come to Unacademy. You can come to Unacademy if you want to. I take regular classes there also, and you can. तो वहाँ पे काफ़ी मज़ा आता है, एक्चुअली काफ़ी बच्चे होते हैं. फॉर एग्जाम्पल इन Unacademy जनरली आई हैव 150 to 200 स्टूडेंट्स in a class, so it's quite competitive. So this is the question. Find the equation of tangent and normal to the curve x equals to 80 square upon 1 plus t square, y equals 280 cube upon 1 plus t square at the point this. ठीक है, तो this kind of equation, when you have given x in terms of another variable t and y also in terms of another variable t, this kind of equation is known as parametric equation. Okay, why parametric equation? Because both x and y are being represented as a function of another variable which is t. Okay, if you get the answer, if you are done with the answer, let me know in the comment section. अरे लॉल, बैटरी 2% है, तो जाके पहले चार्ज कर लो उसको, कोई बात नहीं, वापस आ जाना, कोई बात नहीं. Anyway, so we have to solve this question. The question is a parametric equation and let's try to solve it. So x equals 2a t square upon 1 plus t square, y equals 2a t cube upon 1 plus t square. Oh, badhiya, badhiya, thank you. So again, for equation of tangent, we need a point and we need a slope. So the point can be calculated using t equal to half, which is given. If you put t equal to half here, you will get a x. If you put t equal to half here, you will get a y. But we have to calculate the slope also. We have to calculate slope. The slope is dy upon dx. But this is y, this is x, and this is, they are not jumbled up. Basically, they are not represented as a function of one each other. So how do we calculate dy by dx? So this is a trick. What you can do is, you can calculate dy by dt, you can calculate dx by dt and divide them. So basically dt and dt will cancel out, you will get dy by dx. This is nothing but dy by dx. But if you see, you can, dy by dt can be calculated from here, dx by dt can be calculated from here. Okay, so let us try to calculate dy by dt and dx by dt one by one. So let me take few sheets. Okay, so we have y equals 2a t cube upon 1 plus t square. Okay, so dy by dt would be equal to 2a is constant, you can take it outside, numerator and denominator. So differentiation of numerator, leave the denominator, differentiation of denominator 1 plus t square differentiation. अरे भाई भाई भाई, एक काम करो, तुम रेस्ट ले लो. So 1 plus t square differentiation is 2t, and what is numerator? T cube upon 1 plus t square whole square. What is dx by dt? What is x? X is equal to 2a t square upon 1 plus t square. If you do this, you will get 2a constant, take out t square, differentiation of t square is 2t, leave denominator, 1 plus t square differentiation is 2t, leave the numerator, and this is 1 plus t square whole square. Okay, as I told you, dy by dx is dy by dt divided by dx by dt. Basically you divide them, so it will be this divided by this. The 2 and 2 will cancel out, 1 plus t square whole square and 1 plus t square whole square will cancel out. In the numerator you will get 3t square plus 3t to the power 4 minus 2t to the power 4 upon 2t plus 2t cube minus 2t cube. Okay, I hope this is clear. So 2t cube and 2t cube will cancel out. Fine. 3 minus 2 is 1. So 3t square plus t to the power 4 upon 2t. T and t will cancel out. So you will get 3t plus t cube upon 2. And we have to calculate dy by dx at, nice. we have to calculate dy by dx at t equal to half. If you put t equal to half here, you will get 3 into half plus 1 by half cube, which is 1 by 8 upon 2. If you solve this, you will get 3 by 2 plus 1 by 8. How much is this? 16. 8 3 are 24. 2 1s are 2, which is 24 upon 26 upon 16. And there is a half. So the answer is, if you solve this, you will get 13 upon 16. This is the slope. Okay, this is the slope. Now we have slope. And what about point? What about point? We have x can be calculated. If you put t equal to half here, you will get x equal to how much? 2a t square, which is half square 1 by 4 upon 1 plus t square, which is 1 plus 1 by 4 is 5 by 4. 4 and 4 will cancel out. So this is 2a upon 5. What about y? If you put t equal to half here, you will get 2a t cube, which is 1 upon 8. 1 plus t square is 1 plus 1 by 4, which is 5 by 4. 4 and this will cancel out. 2 and 2 will cancel out. So this will be a by 5. So I have points which is 2a by 5 common a comma a by 5. So the equation of tangent ही निकालना है ना, equation of tangent is equal to y minus y1 equal to slope x minus x1. If you solve this, you will get 5a minus a. 5 and 5 will cancel out. 13 by 6 x 5x minus 2a. If you solve this further, you will get 16 5s are 80y minus 16a equal 13 5s are 65x minus 26a. If you solve this, you will get 80y minus 65x. Okay, 26 will be 10a. Divide by 5, you will get 16y minus 13x plus 2a equals 0. This is the equation of tangent. Similarly, you can calculate equation of normal. It will be equal to same y minus y1. See, the slope of a normal is minus 1 upon slope of tangent. So it will be minus 16 upon 30. Remember, m1 m2 equal minus 1. So slope of tangent normal is equal to minus 1 upon slope of tangent. So minus 16 by 3 x minus 2a by 5. You try to solve this and you will get the equation of normal. This is normal and this is tangent. Okay, fine. So now let's try to do the next question. And the next question is, find the equation of the normal to y which is parallel to this line. Basically, I have to find normal which is parallel to an already given line. We have already been given a line which is 2x plus 18y equal 9, and we have to find equation of the tangent which is already parallel to this. So basically, this is a line which is already given and we have to find a tangent. You see, tangent is also a line, so two lines can be parallel. And when will they be parallel? Two lines are parallel when their slopes are equal. So what is the key idea? We have to make sure that the slope that we get from here should be equal to the slope of this guy, and when we get a slope we will get an x. So we will get an x, and using that x we will get a point. Just remember that most of the time when you get a slope, when you have been given a slope, using that slope you can calculate a point on the curve. Okay. Okay, so let's do it. So suppose this is the curve and this is the point at which, okay, or maybe I shall draw it a bit more realistically. Suppose this is the curve, okay, and this is the point. You draw a tangent here, you draw a tangent here. This tangent has to be parallel to this line. So the slope of this line and the slope of this tangent, their slope should be equal. Their slope should be equal. What is the slope of this line? Slope of a line ax plus by equal to c is, the slope is, what is the slope? Minus a upon b. So the slope of this line would be equal to, oh I'm sorry, it would be equal to minus 2 by 18. So this is the slope of this line and we have to find the normal. Oh sorry, this has to be a normal. Okay, this is a tangent, there should be a normal. Okay, this should be normal. So we have to find a normal which is parallel to this. So we have to equate the slope of a normal and this line. Okay, so first, what is the slope of normal? Slope of normal is equal to minus 1 upon slope of tangent. Wait, let me add some sheets. Okay. Okay. So first calculate slope of tangent. It would be equal to dy by dx. And what is y? Y is equal to x cube minus 3. So dy by dx is equal to 3x square minus 3. Oh boy, my head hurts. So basically this is, just try to have a look at that, then we will move forward. Okay, so this is dy by dx, which means that slope of normal would be equal to minus 1 upon this. Okay, and what is the slope of this line? The slope of this line is minus 1 by 9, which means this, since they are parallel, the slope of this normal should be equal to minus 1 upon 9. So this minus 1 and minus 1 will cancel out. You will get 1 upon 3x square minus 3 equal to 1 by 9. If you solve this, you will get x equal to plus minus 2. You will get x equal to plus minus 2. So we have 2 points. At 2 points, if you at these 2 points, if you draw a normal, it will turn out to be parallel to this line. Okay. So if x equal to plus 2, if x equal to plus 2, y would be equal to 2 cube minus 3 to the 6. 2 cube is 8, 3 to the 6 is 2. Okay. If x equal to minus 2, it would be equal to minus 2 cube minus 8 plus 6. So y equal to 2. So these are the 2 points at which the slope would be equal to, at which the normal would be parallel to this line given. So let us try to find the equation of those two normals. We have 2 points, so basically there will be 2 normals. Both have the slope equal minus 1 by 9. So normal 1, y minus y1. So first point is 2 comma 2, and the second point would be minus 2 comma 2. This is 2 comma 2, right? Yeah, and this is minus 2 comma minus 2. My bad. So y minus y1 equals slope is already given minus 1 by 9, x minus x1. If you solve this, you will get 9y minus 18 equal minus x plus 2. I hope I am audible. Plus x equal to 20. This is first normal. Okay, this is first normal. Now what about second normal? Y minus y1 equal to the slope x minus x1. So if you see these two normal, 9y plus x, this is same. Y and x coefficients are same. The only thing different is constant. So basically these two tangents are parallel, obviously because their slopes are equal. Okay, shall we move on to the next question? Let's move on to next question. So basically this is another concept rather than a question. So the concept is tangent from an external point. So up until now what we have been doing, we have been considering a curve, and that point is on the curve, and we want to calculate the equation of this tangent. So the point x1 comma y1, this point is already on the curve, and we want to calculate the equation of a tangent which passes through this point. But there is another situation in which the tangent passes is coming from an external point, which means an external point is given, and through this point a tangent is taken to this curve. Given a point P A comma B which does not lie on the curve, let me zoom this out for you guys. Okay, so given a point P A comma B, this point which does not lie on the curve y equal to fx, this point is external to this curve. Then the equation of the possible tangents of the curve y equal to fx passing through AB can be found by solving the point of contact Q. So basically this is P, and from here I am writing a tangent, I am drawing a tangent. Okay, so if I draw a tangent, this tangent will touch the curve at exactly one point, and this point is known as point of contact. The point at which the tangent drawn from an external point touches the curve is known as point of contact. The point at which the tangent drawn from an external point touches the graph or the curve is known as point of contact. So now Q is a point of contact. Once we have a point of contact, then we might be able to calculate the equation of tangent. So how do you solve it? You solve it using by solving this. Let Q be x1 comma y1, basically the point of contact. Since Q lies on the curve, this should satisfy y equal to fx. It will satisfy. Okay, y equal to fx will satisfy. Also slope of PQ, which means the P is this point. Okay, slope of P and Q should be equal to the slope of tangent drawn at the point Q. And what is the slope of tangent? The slope of tangent is equal to dy by dx. So we have two equations, one equation from here, one equation from here. two equation, two variable, we will be able to solve x1 and y1, which is the point of contact. Okay, let us see this using an example. So this is the question. You guys try to solve this. Everyone try to solve this. Find equation of all possible normals to the parabola x square equal 4y drawn from the point 1, 2. Okay, so basically you have to find equation of all normals to the curve drawn from the point 1, 2. Now it is really easy to check that the point 1, 2 does not lie on the parabola. If you put 1, 2, the equation won't satisfy. It means that the point 1, 2 is not on the curve, it is exterior, it is external. Okay, so basically x square equal 4y, the graph is something like this, and we have 1, 2, 1, 2, again this will be equal to 1 by 4. So 1, 2 put somewhere here, and at this point I will construct, let's say this is one normal and this is one normal. I want to calculate the equation of this normal as well as this normal. Okay, these are the two normals which, so let us call this guy as n1 normal 1, n2 normal 2. Okay, so what is the procedure? First we have to calculate point of contacts. How will we calculate point of contacts? First thing is the point of contact, assume that the point of contact is x1 comma y1. Okay, since x1 comma y1 lie on this, so the point of contact will look something like this. If point of contact x is x coordinate, y would be equal to x square by 4, because x square equal to 4y, y equal x square by 4. So if x is the point of contact, x coordinate of the point of contact, y would be x square by 4. So this is point of contact. Fine, this is the point of contact. And we also know that slope of normal is equal to 1 upon slope of tangent. Slope of tangent is dy by dx. If you calculate dy by dx, so you have 2x equal 4y. Dy by dx is x upon 2. So dy by dx is x upon 2. This is dy by dx. And slope of normal would be equal to minus 1 upon dy by dx, which is minus 2 upon x. This is slope of normal. And we know that slope of, if this is 1 comma 2, if this is 1 comma 2 and this is some point x comma x square by 4, slope of this line should be equal to slope of the tangent which we calculated. How do you calculate slope of line? Slope of line can be calculated as x1 y1 minus y2 minus y1 upon x2 minus x1. Okay, so this is y2 minus y1, which is x square by 4 minus 2 upon x minus 1. This is slope of normal, and this should be equal to minus 2 by x. Now let's try to solve this. This is a cubic equation. So cubic equation, this is kind of difficult. Let's try to solve this. Oh, so this is simple. X cube equal to 8, which is x equal to plus 2. If x equal to plus 2, the coordinates are x comma x square by 4. If x equal to plus 2, which means which means that y should be equal to x square by 4. So 2 square by 4, which is 1. So this is the only normal. There won't be two normals, there will be one normal. It seems that there will be only one normal, because we have gotten only one value. Okay, so this is the point. This is the point, and what is the slope? The slope of the normal is minus 2 by x. So slope is minus 2 upon x is 2. So slope is minus 1. So you have got a point, you have got a slope. What is the equation of normal? Equation of normal would be equal to y minus y1 should be equal to slope x minus x1. Y minus y1 equal to minus x plus 2. If you solve this, you will get y plus x equal to 3. Okay, pretty simple, pretty neat. So just see what have we done. So there won't be two normal, there will be only one normal. I'm giving you 1 or 2 minutes. Let's see. Try to note it down. Okay, fine. So now this is the other concept. Condition for which given line is a tangent of, so for example, you have been given a line. Suppose I say this is the equation of line and I want you to check whether this line is a tangent or a normal to this curve or not. Okay, I give you an equation of a random line. I say let's say 2x plus 3 plus equal to 7 and I want you to check whether this line is actually a tangent or a normal to the line to the curve x square plus 7x equal 4. Okay, so this is a line. So you have to understand that we just have to check whether a line is tangent or normal to a given curve or not. So what you have to do, so let's try to read it out. Okay, so basically this is a line. We want to check whether this line is actually a tangent or a normal to this curve or not. Okay, so how do we check that? We say let the point on the curve be p x1 comma y1. Let's say the point on the curve is x1 comma y1 where a line touches the curve. The line touches the curve. Then p lies on this curve, which means this equation will satisfy. Okay, since x1 comma y1 are on the curve, this equation will be satisfied. And on the second note, since p lies on the line px1, this equation will also satisfy. So basically we have two equation, two variable. Further, slope of the line should be equal to the slope of the curve. So we have to check all these conditions and then we will see whether these conditions are getting satisfied or not. So let us see this using an example. So we have an example and the example is show that the straight line, so let's read it out by zooming in. Show that the straight line x cos alpha plus y sin alpha equal to p touches the curve xy equal to a square. It touches, which means it is a tangent. It is a tangent. If p square equal 4a square cos alpha sin alpha. This is what we have to prove. This is what we have to prove. So we say that suppose this is the curve and this is the line. This is the straight line x cos alpha plus y sin alpha equal to p. We want to check whether this touches, and if it touches, we have to prove that this thing is satisfied. We say that let's say this it touches at a point x comma a square over x. Why? Because xy equal a square. If you y equal a square by x. So let us say this touches at a point x comma a square by x. Okay. Now you have to understand that this equation will also be satisfied. This means x cos alpha plus a square by x sin alpha would be equal to p. This is our equation 1. And the second equation that you should know, that dy by dx should be equal to the slope of this line. So what is dy by dx? Dy by dx is, if you calculate dy by dx, you have xy equal x squared. Differentiate both sides and apply the product rule. Differentiation of first, leave second. Differentiation of second, leave first. So y dash is actually minus y upon x, and minus y upon x at this point. The point is x comma a square by x. So it would be equal to a square by x on x. So it would be equal to minus a square by x square minus y by x. Okay, minus y by x. So dy by dx is minus a square by x square. Now the slope of this should be equal to slope of this. So minus a square by x square should be equal to slope of this line. What is the slope of this line? Slope of this line is coefficient of x upon coefficient of y minus cos alpha upon sin alpha. This is how you calculate the slope, minus a upon b, coefficient of x upon coefficient of y with a negative sign. So slope is minus cos alpha upon sin alpha. Negative sign will cancel out. You will see that x square is equal to sin alpha by cos alpha a square. This is x square. Okay, this is x square. This is, you have to understand, this is x square. Now what will be x? X would be equal to, since x square is equal to sin alpha upon cos alpha a square, x would be equal to root over sin alpha upon cos alpha a. Okay, this is x. Now what will be y? Y would be equal to a square by x. Y would be equal to a square upon this x. But what did we have to prove? We had to prove that t square equal 4a square. Okay, so the answer should come in terms of, okay. So the answer should come in terms of this. So we can do one thing. We can put this x value. We can put this. Wait. We can put this x value directly in this equation and try to see what happens. Okay, I guess that would be a better thing to do. That would be a better thing to do. So we have already gotten the value of x square. So let's try to do it. Let's try to go to the next equation, erase everything, and let's start from the beginning. So we have the value of x. Let's try to solve this. So we'll get x cos alpha plus a square upon x sin alpha equal p. You will get x square cos alpha plus a square sin alpha equal to px. What is the value of x? X is, x square is sin alpha by sin alpha upon cos alpha a square multiplied by cos alpha plus a square sin alpha. And what is p? X would be equal to square root of this, which is root over sin alpha upon cos alpha a. Okay, now this cos alpha and cos alpha will cancel out. You will be left with a square sin alpha plus cos alpha, which is equal to p root sin alpha upon cos alpha multiplied by a. Now this a and a will cancel out, and you are left with p equal root over cos alpha upon sin alpha plus cos alpha, and there is a a. So what is p square? We have to prove that there is a, if we square both sides. Now if you square both sides, you will get p square equal to a square cos alpha upon sin alpha sin square alpha plus cos square alpha would be 1 plus 2 sin alpha cos alpha. Oh, maybe we have to use our head right now. We have to actually solve it in a proper manner. Let's try to evaluate what we have done. We calculated x, we calculated y. This is the equation. We calculated the slope, which turned out to be differentiation of first plus second. Differentiation of second leave first. y dash equal to minus y by x. Y is this, x is x, so minus e square by x square. We calculated this and we equated it to the slope of this line. We got the answer as x square sin alpha upon cos alpha a square, and then we try to solve the equation of line, equation 1. Equation 1, we got x square plus a square px, x square value sin alpha upon cos alpha from equation number 2, and this turned out to be a square sin alpha p sin. So where are we making a mistake? This is not a mistake. We just have to use our head to actually solve it. Okay, how can we solve it? Tell me. We have to convert this. So at this moment we are here. We have expressed p in terms of a and sin alpha cos alpha, but we have to reach this point, 4a square cos alpha sin alpha. So this has to be converted into some sort of 2 cos alpha, 2 root cos alpha sin alpha, something like that. Can we do that? Okay, let's try to do it. So I can write this as a. If you take it inside, you will get root cos alpha sin alpha, and if you take it inside, you will get, oh boy, this is nice. This is what we wanted, but here it will become cos alpha. Okay, this is not good. This is actually not good. What can we do? What can be done here? बताओ बच्चों. We have to take this to this form, 4 alpha square sin alpha cos alpha when we square, obviously. So but what can be done right now? Let us square both sides. Let's see what happens. A square, this is cos alpha upon sin alpha, a square plus b square plus 2ab. So a square plus b square is 1, 2ab is 2 cos alpha sin alpha. If we do this, we will get a square. Take this as inside, so it will be cos alpha upon sin alpha plus sin alpha will cancel out. We will get 2 cos square alpha. And this is turning out to be, we must have committed some mistake. Let us try to do things from scratch. We must have committed some calculation error. X y equal a square, which means that x is x, y should be equal to a square of x. This is correct. This should lie here, which means this should satisfy. Oh, this is where we have made a mistake. This point shouldn't satisfy this equation. Why? Because this point lies on the curve. This point doesn't lie on the line. So we have to do everything from the scratch. Okay, let's do everything from scratch. I know sometimes mistakes do happen. The point is x comma a square upon x. This is the point on the curve. And no, but this is also true that this will touch, the line will touch. This is kind of weird. Let's try to solve it once again. X dy by dx was equal to dy by dx was equal to minus dy by dx was equal to minus x upon y. This is where we did the mistake. I got it. Basically, if you try to solve xy, you will get x plus y dash equals 0. So y dash is equal to minus x upon y. What is minus x? Minus x. What is y? Y is a square over x. So the answer would be minus x square upon a square. And this slope should be equal to minus x square upon a square. This should be equal to slope of this, which is minus cos alpha upon sin alpha. If you solve this, you will get x to be equal to a root cos alpha upon sin alpha. Okay, now this x comma a square by x, this should satisfy the equation of line also. which means as we did last time, x plus a square over x sine x alpha should be equal to p, which means x square cos x plus a square sine alpha should be equal to px. Okay, now x square, the value of x square is already given. X square value is a square cos alpha upon sine alpha. So a square cos alpha upon sine alpha. I hope this is correct this time. Y equals mx plus p. This is correct. This is correct. Square upon a square. Fine, this is correct. X square cos alpha upon sine alpha plus this a square here sine alpha. This should be equal to px. What is x? X is a cos alpha upon sine alpha. Now let us try to solve it once again. So if you take a square common, this will become sine square alpha. There should be cos square alpha now. There is a cos alpha here and there is a cos alpha here. So it will be cos square alpha. So it will become sine square alpha plus cos square alpha upon sine alpha. This is equal to p a root cos alpha upon sine alpha. Now see, this is 1. This is 1. So you will get a square 1 upon sine alpha is equal to pa cos alpha upon sine alpha. A and a will cancel out. You will get, and this sine and this will cancel out. This will be root sine alpha. So you will get p equal to a by root sine alpha cos alpha. This is again a mistake. I am giving this thing as a homework. Maybe I am committing some calculation mistake which I am not able to see right now. Anyway, I'm pretty sure you guys would be able to do it. Okay, so I hope you liked today's class, and with this I end the class. Thanks a lot.